Okay, the last topic on this section, which has been a long one, is end behavior, okay? End behavior of a function deals with when the function moves on to infinity, okay? How the function ends up in the long run. Okay, and that's going to be when x goes to, let's say, infinity, as x gets very large, and as x goes to negative infinity, or when it gets very small. Where does the function go? What does f of x go toward? Okay, and that's what we're going to take a look at. And I'm just going to go through some examples, and when I go through these, we'll kind of see then what's happening. In my first example, okay, I've got a graph, and it looks like this, all right? Okay, well, we know that this is, similar to a parabola. It looks pretty much like it. Well, as the values of x get bigger and bigger, so as x gets bigger and bigger, what do the y values go? Where does the function go? You could check it, all right, if you had your calculator, and we go to our function, and we put in there a simple x squared function, and we graph it. Okay, there it is. And then we go to our table, and we notice that the larger and larger that x gets, the larger and larger the y values. And so eventually what is happening is that as x approaches infinity, the function also goes to infinity. It goes up like that. It just gets larger and larger. Then, as x goes to negative infinity, okay, as x gets smaller and smaller, so then we go the other way on our table. As x gets smaller and smaller and goes into the negative values, what happens to the function? It gets larger and larger. So that means that the function goes to infinity. This is called its end behavior. Where does it end up at? Another example, it's going to be a function that looks like this. Maybe comes in like this and goes up. Well, in this case, as x gets bigger, as x approaches, forgetting the x, as x approaches infinity and gets larger and larger, my function also keeps going up. There it goes to infinity. Different is as x goes to negative infinity. In this case, as x gets smaller and smaller, my function goes to negative infinity. Okay? Now, sometimes it gets even a little bit different. Sometimes you get a function that might look like this. Okay? You have a graph that comes in like this, and it goes like that. Okay? And in this case, as x gets bigger, what you have to do is you have to see, okay, where's this function approaching? Well, it always approaches a y value. In this case, it's going to approach some y value up here. All right? The equation for this one right here is going to be something along the line of, let's say we have 3x squared over x squared plus 1. Let's graph that on our calculator and see what happens. Okay? So we have this function. We have 3x squared, and we have x squared plus 1. Okay? And we graph that function. And sure enough, it looks kind of like what I have right there. It flattens out. Well, again, the whole idea is that the bigger x gets, so as x approaches infinity, so go to my table, as x gets larger and larger, now we have to go in this direction, okay? Looks like we have fractions there. I'm going to go to this, and I'm going to see if I can get out of the fraction mode. I don't know if I can. But if you were to do these fractions on your calculator, what you're going to see is that these numbers right there get closer, they approach this value. the function approaches 3. Same is as x goes to negative infinity, as x gets smaller and smaller, this function flattens out and it approaches 3 also. And as you recall, when x goes to these 2 points and they approach the same thing, this is a horizontal asymptote. Also, the end behavior of this particular function.